When it comes to monochrome cameras, we have two types of filters, broadband or the narrowband. The broadbands is your standard LRGB filters, luminance, red, green and blue. As the monochrome only shoots black and white images, if we want to produce colors, we need to shoot one color channel at the time. However, it's not so simple because not all LRGB filters are created equal. A good pair of filters should have relatively vertical lines. We can also see a faint blue line here on top. That is the luminance channel that's covered the same area. But have you noticed something strange? Look between the red and the green. You can see there's a gap, whereas between the green and the blue there's an overlap. Why is that? Is that poor manufacturing? No, it's not. This is actually an indication that this is a very, very well thought out pair of filters. This is the spectrum from another film called the Extreme. Look at the green spikes here. Those are light pollution spikes. This is where we commonly see lights from street light. We have sodium that comes from these sodium vapor light bulbs that are being used in street lights. Chroma has basically created this gap just below 600 nanometers, meaning that they just created a gap right where we have a lot of light pollution between the two filters. In a similar fashion, if we go over and look at the overlap between the green and the blue, they sit right on 500 nanometers. Why does it do that? Well, we can see that right there we have the oxygen 2 line, which is probably the second brightest line that you would see from a lot of emission nebulas. And we really want to capture that line, so we're actually going to let both filters capture that line and get data on that line to maximize the amount of output we get out of the oxygen line. It's important that you look for these kind of things. Look for that valley in between there. Look for the overlap. This is also why you can't just mix and match filters from different brands.